All right, yeah, so we're going to talk about branches. There is a metaphor there to like trees. We'll get into it. But as I do with everything in this class, as you've seen so far, I'm going to give you a bunch of examples, and you don't have to write them down, right? I'm giving you all this code. You can come back to them. They're all just examples of computer science, of thinking like a computer, computational thinking, that fancy word. So eventually, I will implant in all your minds like just the thought process, and then you'll be able to write all these programs yourself. All right. So until then, you got to keep studying, but you don't have to memorize anything. It's all to help you for your labs. That's like the big key assignment in the class, and then also your Xi labs. All right. Every test, I don't know if I told you this yet, but every test in this class is going to be open book, open notes. Okay. So you can go look at my starter code and look at all the code from class and look at all the slides too as you're taking the test. But I'll be writing the test with that in mind though. Okay. So yeah, let's get right into it. Let's talk about some cool stuff. You have a question first? Yeah. I will make the tests with the idea that you're going to be using your notes in mind. The questions are not going to be as easy as they would be if you weren't able to use your notes. That's what I meant by that. Welcome. So yeah, I guess first joke slide is: are we getting good at like using text editors? Are we able to save and make our programs work, save and quit and get back? Are we doing better at that? So I do want to tell you right now, Nano is a crutch. It is not good for programming. It just gets you by, and it looks really ugly when you write things because it doesn't like auto indent or do anything nice to you. So all the cool kids use either Vim, or there's also a program called Emacs, which is like a competitor. There's like a decades-long battle between the two, but please do the Vim tutor if you have not yet. It will make your life so much easier in this class. There's also Visual Studio Code. This is a fun meme. Visual Studio Code is a graphical-based editor that a lot of people like to use. If you ever want to learn how to write code on your own computers, I can help you with that, and that would probably be the program that I recommend. Okay. Next piece of information. If you're ever concerned or interested in more information about a terminal command, like I told you about ls and g++, like what more is there to learn? There is a manual page for every single terminal command. So like you can say, and you can look it up in the manual, say, if I want to know a little bit more about ls, I can say man space ls, and it will take me to the manual page for that. And I can just use my arrow keys and Q to quit. So like, oh, I can do ls-a apparently. That would show me some extra stuff. ls-l shows me more interesting information when there's something there. Yeah, man G++, what is our compiler able to do? Look at all the options you can give to G++. Wow, a million things. So yeah, look up your commands in the manual. It's helpful. Man cd. Oh, I guess that one's not there. Man pwd. Cool. All right. So yeah, with that, let's talk about how to ask questions in C++. All right. So wouldn't it be nice if we had options as we were coding? If we could do one thing or another, that'd be really cool. Because right now our programs, they're cool. They get input from the user, and like we can do different things depending on the input. Like we can do math with what the user gives us, rather than just like hard coding the answer all the time. But right now, all of our programs, they look like straight lines, right? So this is kind of what our programs look like. Do thing A first, then do thing B, then do thing C, and that's that. If I were to draw like a flow chart for that, like thing A happens first, then thing B, then thing C, that's about as good as it gets right now, right? Wouldn't it be cool if we could branch off and do one thing or another? That'd be nice. So that's where we're going. For example, right now we have no way of printing even or odd to the user. Like we ask the user for a number. There's no way for us right now to print, oh yeah, that number was even, versus, oh yeah, that number was odd. We can't do that right now. Isn't that interesting? Because that would require us to be able to do the following. Like first we need to get a number, put it in a variable, call it x or something. Then we need to ask the question. We need to learn how to ask questions. Is x even? And then depending on the answer to that question, I need to do one thing or another. If the answer is yes, then I need to like print out even, right? And if the answer is no, I need to print out odd. Yeah? There's no way to do that branching right now. I have not told you how. And then maybe you come back later and continue with more straight line programs down there. Straight lines of code. I mean, you can kind of get close with what you know, but you can't do exactly what I just said. You can make a variable. You can see into that variable. And then you can see out not even or odd. You could see out the result of x mod 2. So it'll be 0 if it's even, 1 if it's odd. You can do that, but you can actually print even versus odd. Okay, so let's do that. All right, here's my silly example from the movie Mean Girls. So let's make a program where we ask the user, is it Wednesday? And if so, we'll say you should wear pink. And if it's not Wednesday, you can't wear pink, because only on Wednesdays can you wear pink, right? So I'm going to teach you how to ask a question, and it's going to involve and do one thing or another, and it's going to involve what's called an if-else statement. All right, so it looks like this. It's a little weird. So this is how it looks. It lets you branch based on what's called a Boolean expression, which is part of a man's name. He invented this idea. And a Boolean expression becomes either true or false. That's our yes and our no in computer science. So this is the program I'd like to write. Ask the user, is today Wednesday? Today Wednesday. If the answer is yes, say wear pink. If the answer is no, don't wear pink. But to us, as computer scientists, we don't say yes, we say true. If the answer is true, in the true case, wear pink. In the false case, don't wear pink. Okay? That's where we're going. And so, yeah, this if statement, if-else statement, keeps that in mind. So you put your Boolean expression here between, you say if, in between parentheses, you put your Boolean expression, that thing that can become true or false. And then you put some curly braces, and you can put as many lines in here as you'd like, but you put the code that you want to have happen when the expression becomes true. If the answer was yes, you put code here, and that code will run. Or if the answer was no, you say else and some more braces, and you put all the code that you'd like to run if that was a false statement, if that was not true. Okay? So the very first piece of this puzzle is, how do I ask the question and get back true or false? Right? That has to do with some relational operators that exist in C++. Here's a bunch of things that produce either true or false. Okay, lots of stuff from math that you know about. Right? So the ones that you don't remember from math, the ones that are specific to programming, are the double equals and the exclamation point equals. All right, so if you say double equals, that's an equality check. All right, we have to do it that way because otherwise that's an assignment statement, right? So we need a second equal sign to mean no, check for equality, don't set a variable. Okay, so for example, if statement, if 2 is equal to 2, that should give back true, right? If 2 is equal to 2, it'll always run this part, right? It'll always run the true part because it's always a true statement. And then the else case will get skipped over, okay? Whatever is here is going to get skipped always because 2 is equal to 2. That's a true statement. The answer is yes, all right? Exclamation point equals, I want you to read the exclamation point as not, so not equals, that's a check for disequality. So is 4 not equal to 7? Yes, so true. That's what C++ will give you back. And then everything else you know and love, right? So is 2 less than 3? True. Is 2 greater than 3? False. There's no real easy way to type this character to C++, and so instead we just like less than sign and then it equals right after. So is 2 less than or equal to 2? Yes, so true. It'll give back true. Is 3 greater than or equal to negative 42? True. Is 3 greater than or equal to 5? False. Okay, so it's always going to figure it out. It's going to do the math for you, and it will give you the answer back. So what we want to do is check for equality on what day it is, all right, and include this little if-else statement. I think we're ready. Yeah, does that make no sense? It's the code we're going to write. Well, let's do it. Out of my web browser. Weird. There we go. So here we go. Let's make a new file called if-else.cpp. And we are going to ask the user what day it is and get that day in a string. So I'm going to include the string library. So I'll be like string today. Whatever day it is goes in there. Cout, enter what day it is. And I can just use cn because every day of the week is a single word. I have to do other things if it wasn't. but that's good. I just get the 1 day, and then I have my if-else now. It's time. So I've got the input. Now I need to check, is the input equal to Wednesday? So I'll do an if statement. I'll say if that day, if today, that's the name of my variable, if today is equal to, quotes with Wednesday, right? Wednesday, then within braces, what do I want to do if that's true? Well, you should wear pink. All right. Else, if it wasn't true, we're going to jump here instead and run this code. I only need one line again. Don't wear pink. Okay. So that is going to be my code. Questions about any of that? Yes. Yeah, this is a placeholder. It's like a blank. Something that becomes true or false. That's called a Boolean expression. Alright, so yeah, this is gonna work, I think. Enter what day it is. Today is unfortunately Thursday. So it says don't wear pink, right? Because today is our variable, it's gonna hold Thursday, because that's what I typed, and it's gonna check, hey, is Thursday equal to Wednesday? No, of course it's not. So false, it'll hit the else case, and it'll say don't wear pink, right? But if I run it again and pretended that today is Wednesday, then it will hit this true case and be like, yeah, wear pink. Okay, that's pretty nice. And then once you're done with the whole thing, once it picks one side to go down, the whole if-else is done. It only does one or the other, and then you're back to just straight line normal code down here. Whatever you want, the rest of your program. Straight line code can go here. Dot, dot, dot. So like, this will always get run because it's outside of the if-else. Done or something, I don't know. So it doesn't even matter what the day was, Thursday. So now it'll jump here, and then the whole thing's done, so it'll say done. Or if it's Wednesday, it'll jump here, and then the whole thing's done because it picked a side to go down. Now the whole if-else is finished, and we're down here again. All right. So that's our first taste of an if-else statement. I think I can finally give you that example that I told you at the start. Let's make a program now that does even or odd. Okay? We're ready for it. Dun, dun, dun. So I'm going to teach you some terms after we do it, but here's the idea. We want to get a number from the user. Get input. And then we'll call the variable input or something, let's say. And then we need to ask a question that is true when the number is even, let's say, and false when it's odd. Right? So I kind of gave you the answer by writing this. It's going to have to do with a mod too. Okay? Do you see how if I have an even number and I divide it by 2 and get the remainder, it goes in cleanly with remainder 0, right? Every even number, you divide it by 2, the 2 goes in cleanly. It's an even number. All right? If I tried to divide an odd number by 2, I'll always have something left over, right? This will be 21 remainder 1, for example. That's how you differentiate between the two, okay? So this will be your check. You'll be like, all right, is input mod 2, is the result of all that equal, double equals, equal to 0? If so, right, the answer is yes, it's even, okay? If it's not, it is odd. So that's going to be my check between those parentheses of my if statement. And then if it's true, the answer was yes, or false, I'll do one thing or another. False. So if it's true, it's even, and I'll print something to that effect. Otherwise, odd. All right. Let's do it. Where is that example? Yes. This is how I explained it. What was confusing about that? I'm dividing by 2. Any even number has 0 left over. Any odd number has 1 left over. That's what modulus does. It gives me that remainder. Does that answer your question?
Yeah, also like how can you really like go about it like do it the way that you're doing it before, like how can you use mod to like.
What do you mean before? This is the only way that you could do this. You mean for like the check if it's equal to Wednesday?
Yeah, like you have to like do mod to check if it's even or odd.
Yeah, because this is a result. Whatever the input was, either I'll get a 0 here or I'll get a 1 here, and I have to compare. All right? We might have to talk about this after class if it's still confusing. I want to move on now, okay? But yeah, that's going to be the idea. That's what we're going to check. And I can give us this program now. All right, even, odd, .cpp. So I need to make space for a number. Let's just call it n. Easier for me to type. And I'll ask the user for enter a number, please. And then I'll get it. And then I will check if n mod 2, right? It's either even or odd. N mod 2 will tell me which one. If that is 0, it went in cleanly. There was no remainder, so it was an even number. So that's my even case. Else, it's my odd case, all right? And so if it's even, I'll see out even. Whee! And then if it's odd, I'll see out odd, all right? And I think that'll be the full program there. So let's compile it. Even, odd, enter number 42. That's even, because 42 mod 2 is 0. Perfect, true, so even. 43. That'll get 1, right? There's 1 left over. 1 is not equal to 0, so the answer is false to compare it with 0. And so I hit the odd case, and I print that. Isn't that beautiful? We can do that now. So I do want to teach you some terms about this. I've been saying some words. Those are technically correct words, but there's more to it, right? So this check, the thing between the parentheses, that is called a condition. That's your conditional part, right? That's the question that you're asking. Could be true or false. That's called your condition. Condition. And then the pieces inside, the stuff that gets run when it's true and the stuff that gets run when it's false. I guess the metaphor is like the condition is like the head, and like the other two cases are your body, I guess. But we call these two pieces, this is the body of the if parts, right? The body of the true branch. But body is a new term. Body of the if, it's like the meat, what you want to have happen there. And this is the body of the else. Okay, so I'll say those words from now on. So yeah, if it is even, we'll run this branch, execute this body, otherwise we'll execute this body. Cool. So there's that, that's if else. I do want to say that you don't have to use the else if you don't need it. If you don't have anything to do when it's false, you only want to do something only if it's true, then you can just not use the else. All right, you can just do this. If, give your condition, and then if it's true, it'll run this, and then you're just like closing brace, don't even have an else, then it'll just run the body only if that condition is true. Otherwise, it'll skip all the way to the rest of your code. Okay? So you don't need to have else always if it was just going to be blank after all. Okay? How do I want to show the next example to you? I guess I'll do this one. So, unfortunately, more than what you would expect could be true or false. So C++ tries to be nice to you. It's probably not the best thing for a CSCI 40 student, but C++ is able to convert numbers to true and false, which is very confusing. All right, it's going to implicitly convert values, integer numbers, to either true or false if they're part of a condition. So technically, this is possible. You can say, let me go back to my default color. You can say if 42. That's very weird. And then have a body. Boop, 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 boop. And the body will run, right? Because everything in C++, every number other than 0, it considers to be true. So this becomes true as far as the if statement is concerned. True. And it will run that body. Crazy. 0 is the one number that C++ thinks is false. So if you have this, if 0, it will never run its body. And maybe you had an else, though. It will run the else always. So that's very disgusting. And you should never use this. But now you know. So that's 0. That means false. That's just wrong, right? Let's see. So, with that in mind, I think I'm ready to ask you a question. I've shown you a lot. Let's help each other and see if we can get this answer right. try to run the code in your mind, because that's what makes you a better programmer. So I'll stop attendance after we finish this, so make sure you've done attendance. But let's go to that by clicker page, and then I'll let you get into peer instruction groups and help each other. Here's my question. Here's some code. What will it print? Not horrible, right? So tell me what it'll print. Try to run the code in your mind and convince your neighbor that you are correct. Okay? A few more seconds. Our conversation seemed to be dying down. Recording, right? Oh, yeah. Ooh, exciting. All right, I think that was enough time, yeah? We ready to see what we believe? I guess there's time to check it in code, but I want you to learn how to run code in your mind. That's like the best way to get better. It's like walk through it. That's going to make you better at everything, all right? Whee! And I promised to also stop that. Well, let's see. Ooh, one of us thinks C. That makes sense. We're thinking B with a majority, all right? But some of us think A, so we're not so sure. Let's figure this out. I will make a new program and copy this into that program. When I copy from PowerPoint, sometimes it's unhappy about spaces. 42.cpp. And then I'll paste that here. And yeah, because it like makes the fancy quotes. That's disgusting. And then I think it's mostly happy. Pay no attention to the underlined statement. 42, 42. So, all right. Was it A? Was it B? Let's figure this out. It was 42. Oh no. So the issue is actually my editor is Vim is very nice to me right now. It's telling me that part that's underlined right there, that condition, there's something wrong with it. Can anybody tell me what is wrong with that condition? Yes. Very good. So to check for equality, what is the operator? 2 equal signs. I have used 1 equal sign. What does it mean when you use 1 equal sign in C++? It's an assignment statement. Oh no. Okay, so answer was A. This was a trick question, but we're all going to remember this now. So yeah, this is another reason why I hate the assignment operator. It should have been an arrow. It should have been an arrow. And you could have used single equals to check for equality, but no. All right, so double equals checks, and single equals is always an assignment. All right, so there's a lot of things at play here. There's a lot of reasons why this messed up. You were allowed to do some weird stuff. Okay, so we had x. X did hold 41. That's how it started its life. And then we went to this line, if x equals sign, 1 equals sign, 42. So first new piece of information that you should never take advantage of, you can put whatever you want as a condition. you can put just arbitrary code as a condition, including an assignment statement, because why not? You should never take advantage of that in this class. Only wait until you know more. All right, so that's something you're allowed to do. And then that means this is going to get run. So as the condition gets executed, this will get run. And so x will become 42. It's going to get set when you didn't want it to get set. And then the result of your assignment statement is the right-hand side of the assignment statement. Everything that you have in C++, it usually is able to give back a value in terms, even an assignment statement. Like you could see out, if you wanted to, the result of an assignment statement, and it would work, and it would print something. And what it prints is the value that it gives back. It always gives back the right-hand side. Okay. So the right-hand side of the assignment statement is the thing you're setting. So this, as far as C++ is concerned, sets x to 42, and then the result of that assignment statement is the value you just set. So the result of that is 42. So this if statement sees next, it's as if you said if 42. Because after that assignment statement does its job, it gives back the value that you just set, 42. It's equal to its right-hand side. And then we see this, right? And then C++ sees that as if true, right? Because everything that's non-zero is a truthy kind of number, truthy versus falsy. And so it's going to hit the body and also set the variable. That's horrible, right? We're all going to watch out for this now, yeah? So that's one thing. And then also, the wonderful thing that you can also do is if you did this, think about it. So if x equals 0, it will set x to 0, and then it will run the else case, because 0 is a number that's falsy, so you think that it wasn't, but it was after all. So that's just wrong, right? So that's disgusting that all this is allowed, and the only thing that you can gain from this, the reason this all exists, one at least, reason why it exists in C++, and you're able to do all this, is there's a way to set multiple variables at once on a single line. So you can declare multiple variables with a comma like that. Hopefully you've read about that in your book by now. And then you can set them both to the same value by doing this. You can chain assignment statements. You can say x equals y equals 42. You're allowed to do that. And the reason this works is exactly the reason this works, all right? Because C++ will start drawing parentheses like this. It'll do this part first, and so it will set y to 42, and then the result of this inner assignment becomes 42, and that's why it will also set x to 42. So you can just set a bunch of variables at once to the same value on the same line with a bunch of equals. That's why this is allowed. If only we could like turn it off for CSCI 40, but we can't. Okay, so yeah, just watch out. If you're checking for equality, tap that equals sign twice. Okay, this is going to come up. This is just a common error that I see, and so there's a slide dedicated to it today. All right, does that make enough sense? It's disgusting, but I hope we see it now. What do I want to do next? All right, let's get fancier. So you can put arbitrary code inside of your if statements, which means you can put more if statements. All right, why not? So here is a condition. If, obviously this is not C++, just like it's pseudocode. If x is even, you could have as part of your body anything, including another if-else. All right. So let's try to break down, because this is how we learn. Let's try to break down as a flowchart what's going on in this code. So this is our outer if statement. It's got a body, and then there's an inner if-else statement. So it's going to check this, assume this is real C++, run the body if that's true, otherwise it'll run that, and then we eventually hit here one way or another. Okay. So here's what's going to happen. Here's how I want you to think about how it's going to run. So every if statement, if I go back to my examples, every if statement does its question, asks its question first, because it needs to figure out, do I go down the body or not? Which side do I go? So this is the first line that gets run, and it asks this question, is x even? So we come into the if statement, hey, is x even? Question mark. And that's either true or false, right? True or false. True or false. Okay, I'll draw an arrow later for that side. So if it's true, then we hit the body here, yeah? So if it's true, then we hit the body, but the body is another if-else. And so how do we run an if-else? Again, we are going to run the condition first, because we have to check that condition to see, do we go down side 1 or side 2? All right? So the next question we ask in the true case there is, hey, is x positive? Bless you. And so then we again have a true case and a false case. True branch and false branch. So, all right, if that's true, it is positive, then you know, if you got here, right, just by virtue of how you got there, you know that that number x must both be even and positive, don't you? Because the only way you hit this body at all and ran this inner if is if it was even to begin with, and then the only way you got here is if it was also positive because this was true. Does that make sense? So that's checking multiple things now, isn't it? And then if it was false, what do you know about x? You know that it was even because you still got to the check, but this one failed, and so it was not positive, but it was even. So it was even and then either negative or 0. Okay, do you see that? And then after that, this whole thing is done once it picked a side to go down, and then we go straight to 3. Whatever that is, that's the rest of your code. Always. Boop, boop. If at the very beginning this check for evenness was false, it was odd, then we just go straight to 3 because we skip over the body of the if, because it only gets run if it's true. So if that was false, we go straight to there. Okay? Do you see how I'm reading that? That's what I want you to get good at, and just practice is the way to do it. Okay? So, yeah, let's do that, and let's nest. It's called nesting if statements. And let me show you that, and then I'll show you a way to like get rid of nesting. It's called else if. Okay, so here, let's make a program that works like this. Let's ask the user for what day it is, and then we will like abbreviate the day. So like you're making a calendar program, you need to do this. So like if you see Monday, let's spell Monday correctly first. So let's say if the user types that it's Monday, you want to output that it's just mon. Like you want to shorten the day for your calendar. It doesn't have a lot of space, let's say. Okay. If it's Tuesday, you want to print 2 or something. Okay. So that's what I would like to do. And so there's 2 ways to make this kind of program that does this kind of thing. The first way is just nested if else's. So kind of this is how it's going to execute no matter what. But there's like a better way, and then there's the way we can do right now using our current knowledge. So it gets better. So let's say we got the day from the user in a day variable. Well, we need to check like what day it is because I want to abbreviate that day. So if the day is Monday, then if that's true, then I want to output mon, right? But if it's false, it could be Tuesday, Wednesday, Thursday, I don't know still. I need to check more, right? So I need another check now. Okay, if that's false, it wasn't Monday, then maybe it's Tuesday. Let's check that. So this is going to be another nested if statement. Then Tuesday. Hey, is it Tuesday? Double equals. If so, if that's true, output 2 and call it a day, right? Then you're done. Otherwise, if that's false, then all right, it's not Monday or Tuesday. Maybe it's Wednesday, Thursday, Friday. Just in some order, you got to check the rest. So again, we have another if statement. You see that? All right. Then maybe the day is Wednesday. And if that's true, this is running out of space here, but you kind of get the idea. If that's true, then you got to output wed. If it's false, then it could be Thursday, Friday. You see the pattern, right? So let's code this. All right. I'll call this else if because this is where we're going. But let's get a day from the user. I need it in a string variable, so I'll include the string library. So string day, and I'll ask the user to enter a day. Doesn't have to be today. And I'll get it. It's just one word, so I can use cn. And then, all right, let's make this happen. So first thing we need to do is check, hey, it's today Monday. Could be true, could be false. I need an else if. I need an if else. If day is equal to Monday, then, well, in that case, it's mon, and we're done. See out mon. All right. Else, if that was not true, that's where I put all of this. You see that? If it wasn't Monday, then I got to check and figure out what day it really was, and do the print in there, all right? If I'm in the else case here, that means it wasn't Monday, and that's all I know. It just means that this one failed. It was false. It wasn't Monday. I don't know what day it is still. I got to check more. Was it Tuesday? Wednesday? Question mark? ... So that's, you start nesting. So now, all right, it wasn't Monday, but maybe it was Tuesday. So if day is equal to Tuesday, in that case, all right, if that's true, then see out 2, that's its abbreviation, right? Otherwise, you see how if I get here, again, I know it wasn't Monday, it wasn't Tuesday. I need to check the rest still. It wasn't Monday or Tuesday, but I'm still not sure. I need to check. Okay, maybe it was Wednesday. So I just keep in those else's. You need to put more ifs. You kind of see it, right? So let's code this up. I'm going to zoom out a little bit so you can almost see all of it. I have to bring binoculars next time. So if day is equal to Wednesday, then see out wed. All right. Otherwise, you get the pattern now. All right. If it wasn't Monday, Tuesday, or Wednesday, maybe it was Thursday. And let's pretend we're only talking about weekdays to save me typing. Thursday, then see out the new line. Otherwise, if it wasn't Thursday, let's just pretend that only weekdays are possible, so it must have been Friday. All right. See out Friday. Make it easier on me. Must have been Friday. And so this is the program. It does, as you would expect. It's going to do it right. It's just long and indented and kind of ugly. But it will do the right thing. You can make this work. I have just made it work. We enter a day, Monday. And so you see how it's going to hit Mon. It's like, all right, I do that. I went down this branch, so I'm going to skip over the else. And nothing else gets wrong. All right. Then if it's Tuesday, I'll output 2 by, all right, this one was false, so I'm going to try this guy, which gives me this if else first. So I'm going to check Tuesday. All right, it was 2. I go down this branch, and then I skip over the else because I only go down one or the other. That's why it's only 2 being output. All right, same for Wednesday. If I spell it right. Wednesday. Wed. So, all right, this was false, so I'll try the else. This is another if. So, all right, this was false, so I'll try the else. I'll try this if else now. Wednesday. Okay, it was true. So I hit this one, and I skip out on the corresponding else because it's always one or the other. That's why it's only one thing that's ever going to get output. All right. Thursday, Friday. Cool. All right. So that's the code. Do we understand it so far? It's nested. It's a little weird, but we can make it better. Question?
I just have a quick question. So in this instance, what would happen if you put Saturday or Sunday? Would like be output?
It'll output Friday.
Oh, because that's the else.
That's the else. It's like, all right, anything else? If none of those were true, I'm doing here because I'm just assuming that that's the only other option. But if I type garbage, it's going to hit Friday because that was like, there's no condition along with this. It was just like, otherwise do this. Okay? So I'm trusting the user right now. Maybe we should. Good question. All right. There's a better way, though. There's a better way to do this. It's going to execute in the same way, though. This is a very common pattern in computer science. It's like we're trying a bunch of alternatives and we want to do one thing based on the first alternative that matches. Okay? So this is the long way, and I needed to teach you it so that I can show you a shorthand that looks more like the English that you want to do. Like if day is Monday, then output Mon. Otherwise, if today is Tuesday, do 2, and then you don't have to indent. Like I'll show you a statement that kind of corresponds to the word otherwise. All right. So let's do that one. It's called else if. All right. So here's what you got to change. You still do your first one normal. You say if day is Monday, blah blah blah. Give your body. And then instead of saying else, if I can spell else, and then nesting more ifs inside of that, here's what you can do. You can say else if together. Else space if. And then you give another condition. And I want you to read else if as the word otherwise, right? It's like, all right, otherwise, if that one didn't work, try this one. And if it does, just stop. If that one didn't work, otherwise, else if, a new condition, try that one, right? Braces. And you give as many else ifs as you need, all right? Until you give up. Once you give up, you can have your else case at the very end. If none of that worked, your last otherwise is just an else. Else, if none of that works, here's my fallback case, ... Okay? Else if, read it as otherwise. And so here's how you do it. Let me translate this code to use else if. Boop. So we got that one. I'm just going to paste it down here and do it again, but using this new idea. And it's going to save us some stuff. I can even zoom, can't zoom in that much. Boop. All right, so this is how we do it. So if day is Monday, output Mon. Otherwise, check if it's Tuesday, output 2. That's my second option. So I'm going to do this. Else if, together, if that's true, output Tuesday. Call it a day. All right? So I don't have to indent that much anymore. All right? If it wasn't Tuesday, otherwise, else if, maybe it was Wednesday. Output Wednesday if so. See how I'm converting it? This is the easier way to think about it once you get it. Otherwise, if the day was Thursday, then, all right, none of those worked before. Maybe it was Thursday. Otherwise, if it was Thursday, output the, and then you're good. And then finally, your last otherwise, just it must have been Friday. That's my fallback case. Output fry, and I don't need as many braces either. Which would you prefer? I don't know. Maybe the first one makes more sense to you right now. I have no clue. But eventually, you will grow to love this version, right? But this is how you read it. Like, if day is Monday, then you do this one, and then you skip out of all the other ones because these are alternatives, all right? So you're always going to hit one of the bodies only. All right. Otherwise, if it was Tuesday, then output this, then I'm done. Otherwise, if that wasn't true, maybe it was Wednesday. If so, output would. And if it was true, then I'm done. All right. It's always going to hit one of those bodies. That's else if. Boop. And so regardless of what I type, Monday, it's going to output the same thing twice because these are equivalent pieces of code. They are executed in the exact same way. This is just shorthand for the one that I did first. Tuesday, Thursday, that's what today is. Friday. Friday. Okay? Any questions about that? It's probably just going to take some time to read about it and go through examples. Question? Because I copied and pasted the code. I did the first one as the first example still here. And then this is just the equivalent code again, so it's going to do the same thing twice. All right. Okay, your turn. Here you go. Please humor me and open up the written nice page. You guys can work together. Can elect a leader to enter in your answer. Let me clear this out. But here is my question to you. Let me give you, in a very small way, this code. This is what I want you to use as your template, I guess. Here's this. I'd like you to write a program that calculates somebody's grade, maybe yours. Like this code is in Canvas somewhere secretly because it's always calculating your grade as a letter, right? So let's say that we live in a world where we're taking a weird class where you can only get an A, a C, or an F. That's all you can get, okay? So I would like you to write some code that using a double variable called grade, you can either like get it from the user or just imagine it's there and just write the ifs if you want to. But pretend you have a variable called grade that's a double, because your percentage in your class might have decimal places. If your grade is between 70 and like 89.9999 on forever, but not 90, output C. F if it's less than 70, you say you fail it when it's less than 70. And then A if it's greater than or equal to 90. Extra credit counts, I guess. All right? So that's what I want you to do. And I claim, you'll have to rearrange these, I claim that you can get away with using these as your conditions. You might not even need one of them, actually, if you do it in the right order. But, yeah, think about it. This is what I want you to output. And I'd like you to, work together, help each other, maybe elect a leader, and enter in some code on that written nice page for your group's little slot. And let's see if we can get like an if else kind of thing going on here because you got 3 things to check. All right? See if you can output the grade based on the grade variable. We good? Questions about the question? It's a double. So what goes in there? You'll have to think about what kind of number goes in the double variable. I think that is what I want to say. No. A way to use those exact conditions that I have in blue there. There's also a way to not use one. See if we crash the website. What was the Discord question? Water. Yeah, 120 those. All right, that's my timer. Let's see what we thought. Press that submit button. If you're brave. Let's take a look. I think, yeah. Group 5, good job. I see that you got that one. Oh, nice. Group 6, you got actually the grade. And you put one in there and you were checking it. So, yeah, you see that the A case is going to have to be the first case. Otherwise, the other one's going to, like, dominate the other, and it's always going to output C. Okay? So that is going to be the answer. Yeah, I think most of us got that. I'll show you what happens if you do it in this order. It's not going to work. All right? But, yeah, good job. Thank you for that. I guess I need to go back here, but I can go back to the home page. So, let's code it up, and I'll do it the first way with that exact order, all right? And then we'll see that there's an issue. So I would like to make room for a grade variable, and I'll ask the user so nicely for their grade as a percentage from 0 to 100. I'll cn into the grade variable, and now I want to convert grade to either A, C, or F. It's a weird grading scheme for a class, all right? So if we just did it in this order, and we use these conditions, there will be an issue. So if grade greater than or equal to 70.0, see out that it was a C, right? That was that one. F, the other one, else if, right? Otherwise, if grade is less than 70, then output not A, F. And then you can end in an else if, that's fine. Else if grade is greater than or equal to 90, then see out A. But usually you want to make like your last one, if there's only 3 options, your last one's probably always going to be an else. And you need to think about like how to do that. But you can keep it else if, that's fine. It might skip it over though if you do it wrong. It might not do anything. So if you always want there to be a follow through case, it should always be else at the end rather than an else if, just to make sure. So there's that. Let's enter a grade, I don't know, 42.5. That is correctly an F. It's not greater than or equal to 70, so it'll hit the F case, all right? 75.67, I don't know. That is correctly a C. Greater than or equal to 70, print C. The issue is the A, All right, so if it's a 95 or something, it's still going to print C. Can anybody tell me why? Yeah. Okay. Very good. There's a priority order when it comes to your if statements, right? The very first thing that happens is it checks this first condition. If it's true, it runs the body. Is 90 greater than or equal to 70? 95? Absolutely. So if you want A first, you better check A first. Like the hardest thing to do, to go in order kind of, A better be first, right? So that is kind of what needs to happen. So do 90, then we have A, and then honestly, you could keep it like this, and it would work for C and F, because this is like, these two are mutually exclusive, if that makes sense to you. Like one is always true and the other is always, they never correspond, they never overlap. Like this is the opposite condition to that one. Yeah. So you can have those in either order, that doesn't matter, but usually you'll do it like this. It's like the common way to do it, I would say. Just like go in order. And then also, because the opposite of this is it was less than 70, you don't even need else F. You can just say else. Okay? See out F, and this will work. 90. We want to be very specific about it being doubles. You don't have to be, but we can just put a .0 everywhere. And now it'll be happy. Now 95 is an A, a 75 is still a C, and like a 55 is an F. Okay? Questions about that? So yeah, there's a way to actually keep this order, and I will show you later. If you want to do it this way, you have to change your conditions in a weird way, and so it's better to just learn this way first. Okay. All right. If we are good, I have one more little section of things to talk about. I would like to teach you about a special type that holds Boolean values. That's the term that meant becomes true or false. Yeah. So it's a cute little type. It's called bool. It's short for Boolean. Boolean. That's how you say it. And yeah, it's a type just like int and double are a type. It's a very small type. So we know that the int type, it's like the cloud where all the things that are ints live. What are ints? 0, 42, negative 40. Lots of numbers are ints. A couple billion of them. The bool type is a very small cloud. All right. The bool type only holds two things. It only holds true or false. You got your true, you got your false. Okay. And so you can hold true or false in a Boolean. And you can do it like this. You can set a variable like bool, that's a type name. Bool b equals the result of something. You can put whatever you want. You can put true or false, or you can put any expression that results in true or false, just like the stuff that you would put in a condition. You'd be like, all right, bool b equals the result of checking, hey, is 42 less than 43? Because this will become true or false, just like 2 plus 2 becomes an int 4. Yeah, so this will become a Boolean, and you can actually condition based on this. Now you can be like, if b. Like this will get replaced with whatever b holds, and if b was true, if statements will run their bodies, right? That's kind of interesting. And so b, this variable, is going to hold true because 42 is less than 43. It is a variable that will hold on to true. And so if you want to save a condition in a variable, this is the type for you. Okay. Let me show that to you. Yeah, bool.cpp. That's what I'll call it. And so I can set a bunch of bool variables. Bool b1 equals this. That'll be true, right? Bool b2 is, I don't know, 45. Is it greater than or equal to 55 or something? So that'll be false. And then you can also just hard code it and be like, all right, bool b3 equals true. Bool b4 equals false. Okay. And you can print out their values if you'd like. C++ by default prints out booleans in a weird way. It's going to print a 1 if it's true and a 0 if it's false. By default, you can change that. You can also use an if statement to make it print however you want, can't you? I see 1 printed because b1 was set to true, and then b2 was set to false, so I see a 0 printed out. Okay. But of course, you can put this in your body, or you can put this in an if statement and have a body run based on whether it's true or not. So you can say if b1, and this is the same, right? It's going to run if b1 is true, right? B1 was true, new line. Because, right, B1, it's like, what is this condition? It just looks up B1 and replaces it with that. And if B1 was set to true, it's like if you said if true, right? And if statements run their bodies if things are true, if the condition is true. So that's how that works. And B1 was true, wasn't it? So it should print that out. This is instead of doing kind of this, right? This is redundant, and I hope you see why. Because B1 itself was true, right? And this is saying is true equal to true. It's kind of redundant to do that. And so a cleaner way that most computer scientists prefer is instead of checking, hey, was B1 equal to true? You say if B1. It means the same thing, right? Because if it gets replaced with true, and that's what B1 held, then it will run the body, because if statements run their body if the condition was true, okay? I know it's weird to think about. And then otherwise, we can do this. We can condition on B2 if B2 was true. I read it like that, right? I don't have to type this out. This is redundant. If B2 was true, like this will get replaced with that truthy thing, and then it will run the body. See how B2 was true, but B2 was false, wasn't it? And so I can add an else statement, just in case, and I'll need it this time. All right, so that's how you kind of read it. Read this thing as if B2 is true. Do this thing. And go back to the example if that is still a little confusing. That's how they execute. So yeah, B2 was false. All right. So that's Boolean variables. This is a brand new type capable of holding true or false. Questions about that before I show you one last cool thing? Yes. That's just the default way that C++ prints Booleans. Yeah, 1 for true, 0 for false. You can change it by using an if statement. Then you can say true or false. There's also a deep down way, just like fixed and set precision. There's a way to configure it to print true, but I don't remember that off the top of my head. You can look in the documentation. Okay, yeah. Let me show you one last thing. All right, so here is some code that could be made better on the left. All right, so I think I showed that to you up here somewhere, right? Something like positive and even. Where was that one? This one. So you can kind of tell, if you want to check two things, you're gonna have to nest your if statements right now, even and positive, right? Like this thing on the left. If it is even, that's my even check right there. Do I need a different color maybe, just so you can see it? That's even check, right? And then if you hit this body, you're even. And if you also want to check something else on top of that, you kind of have to add a new if statement right now. Like this is positivity check. And only if you're in here do you know, right? It was both even, because you wouldn't have got to the check otherwise, and it was also positive, because we hit the body of that positive if statement, okay? So when we get here, we know that we're even and positive, okay? That's kind of unfortunate that we would have to make two if statements to check two things, make sure they're both true, right? There's a faster way. It's called the AND operator. It's two ampersands, right? So you read it as and it works exactly as and would, you would expect the word and to work in computer science. So you just put your two checks, this is equivalent to this, you can just put your two checks, one after the other, and combine them with the and statement. So it's like if num is even and num is positive. Okay, and it'll be true if they're both true. Right? If this is true and this is also true, only in that case, you read this as and, then you run the body and you know they're both true. Okay, that's how you combine your conditions with the and operator. All right, that's pretty nice. All right, I do need to show you a table though that we're going to learn. We're going to see more of these. It's called a truth table. All right, I need to tell you what does the double ampersand do under every circumstance, all right? And prove to you, it's only going to get run, this body only gets run if they're both true, right? I can prove that to you with a truth table, all right? So here's the table for and. Here's every possibility of B1 and B2, all right? You can think of B1 as being all right, this is checking for positivity, B2 is checking for evenness, and this is their anded together condition. So here are all the possibilities for B1 and B2. Either they're both true, one's true, the other is false in some order, or they're both false, all right? And the truth table for and is only going to give back true if they were both true. That's what ampersand does. It checks, were they both true? If so, my final bigger combined answer is true. Okay? Which makes sense. That's what and means in English, right? If any of them are false, right? If B1 was true and B2 is false, then it's obviously not true that B1 and B2 were true. Yeah? See how I'm kind of reading that? And then if B1 is false and B2 is true, it's of course false. It's not true that B1 and B2 are true, because like B1 was ruining the party. And of course, if they're both false after that, like it's not true that B1 is true and B2 is true. Okay, that's kind of how you read it. So that's your truth table. And so hopefully that helps you understand, like, the only way you got here is if this was true and this was true. It's the only way you get true back from their and, from anding them together. All right, so let me print that out to you. I'll print out the truth table. Let's see out true anded with true. So this is the only one that's true. All the other ones are false. So anded with false, that one's false. False anded with false is false, and then you also have false anded with true in between. It's like the default order. So only this one's going to be the one. Only this one's true. The rest of these are false. So I will see 1, 0, 0, 0. Print it out. All right, that is and. It's when you want to combine conditions and make sure two things were true at once. Only then do we want to do something special. All right? And I think that is what I wanted to say in lecture today. Are there any questions about any of that before I move on? And we'll wrap this up next time. But for now, I would like to release your next lab. So lab 1, check the due date. It's August 30th, so that's next Friday, right? That's going to be the pattern from now on. And 5 p.m., remember the due date for most of us. So here's lab 1. You get it in the same way with the gimme commands, like you get to where you want to go and get it. And then you will have some starter code files in that folder. Let me just go to where I've saved all of my starter code files. You'll use the gimme command, of course. So 4001 10. Here are the 2 files that you will get for this lab. 2 pieces. Random average and sales tax. So there's 2 parts to the lab this time. So first example, the first thing I want you to do is get some practice with random numbers. And like see the random number generator, output numbers between a range. Very useful stuff to know. So here is your assignment. You're going to be doing this in the random average.cpp file. All right. Your job is to generate 5 random numbers between 1 and 100. You better seed that random number generator so it's different every time. And you better hold on to these 5 numbers in some way. Because I'd like you to output the average of all of them, whatever they were, rounded to 2 decimal places. So you're going to have to remember you can't just like print out a call to rand or something, right? Because you need to save them so that you can calculate their average, okay? Rounded to 2 decimal places, so use that fixed and set precision thing. So yeah, I've given you a bunch of hints in the CPP file. I've finally given you files with actual stuff in them, rather than blank files like last time, where you were forced to do everything. The rand function and srand are in C Standard Library. You can click the documentation page for that. And kind of here's how it should look. You run it, it's different every time, 5 different random numbers, because it's random. And you seeded it. And like the average should always be to 2 decimal places, even though, because you're dividing by 5, there will never be a 100th place. It will always be 0. I want to see the 0 still. Always 2 decimal places. Okay? So, in the file itself, you actually have stuff I've given to you. You're welcome. So here I have seeded the random number generator. You don't have to deal with that. And you're just going to fill in these fix me comments. Generate 5 random numbers, put the code. And then you output this, and then output your numbers. You got to remember them. And then here is the average stuff. So just like follow the comments. It shouldn't be too bad. Okay. So let's not change this, but that's going to be your random numbers file, and compile and run as usual and get it working. Okay. Questions about this first one? All right, second part of your lab is slightly fancier. It's going to be salestax.cbp, and this is a fun one. We're going to play pretend. We're going to pretend that we live in a universe where we have given up on having pennies and nickels, all right? I think Canada already got rid of their pennies, right? But we're going to pretend we have no pennies or nickels. All that we could ever have in terms of cents is a multiple of 10, okay? So this is what we're going to do. We're going to write a sales tax calculator for a world where you can't have increments of 1 or 5 cents. Only 10. That's the biggest one you can have. So you're going to get an input from the user, like you're writing a program for like a checkout machine or something. You're going to get a price from the user, like that's their final price, their subtotal, and you're going to calculate 7.75% sales tax. I know it's much more in Fresno now, but we're pretending, right? We're going to also, though, pretend that we live in a world where there are no pennies or nickels. So we have to round. The price should always, like the user's entering a price without any nickels or pennies. But the sales tax, 7.75%, is probably going to have some long decimals right after it. So you need to round the tax to the nearest dime. Okay? Not the nearest whole number, the nearest dime. All right? So for example, if the price was $12.20, let me break open a calculator for a second. If the price was $12.20, to calculate 7.75% sales tax, hopefully we remember you're going to multiply by 0.0775. Okay, we've seen this before, hopefully. So that's how you calculate percentages. And so this disgusting number is the technical answer. It's like a repeating fraction even. And so we're rounding it, though, to the nearest dime. So instead of 94.5-ish cents, we're rounding it down to 90 cents. Does that make sense? That's the output. So that you should see 90 cents there, and you add them up and you make it look pretty. All right? That's what you're doing. You're rounding to the nearest tenth rather than to the nearest whole number. All right? So there's a couple ways to do it. I encourage you to use the round function, like I showed you before, but the round function only rounds to the nearest whole number. So there's a trick involved, and I'm going to have you figure out that trick, okay? So the CMath library tells you how to use the round function, but I've also shown you how as well. So that's essentially what you're doing. You're getting a number from the user. That's the price. There it is. It's in a double variable. And your job is to calculate that 7.75% tax, round it to the nearest dime, all right? And this is what you got to do. You got to output it very pretty, make it look nice. So you're going to output the original price with a dollar sign in front, the rounded sales tax with a plus on the left side, a bunch of equal signs that looks nice, and like the final total is this plus this. So you got to save them somewhere, okay? And then the final total price, okay? So just keep that in mind. Try to match the screenshot because there's some spacing issues that you'll have to deal with, and the auto grader is very strict. But that's how it should work. It's just that calculation. That's the hard part. You're going to have to figure out the trick. All right. So, for example, if the subtotal was $47.30, again, 7.75% of that is $3.66-ish cents. But again, we live in a world without pennies or nickels. So we have to round up this time. Round it up to $3.70. See that? 370. That's your final total. And then finally, if it's 54.30 times 0.0775, then it is like you got fractions of cents. You got to round it down now to $4.20. Okay, that's the answer. So that's how it works, and that's how it needs to look. Are there any questions about that? There's a trick involved. You have to figure out that trick. But that's the two pieces of your lab. So try it out. Try to get it to match those screenshots. Compile and run as you know how. And yeah, you'll be turning those two files in. It's lab 01 this time at CSCI 40. And I think that's what I wanted to say. Any questions about any of that? You know what we're going to do? All right. I do have a hint down here. This is a hint for how to round to the nearest tenth rather than the nearest whole number. Read that, and it might help. All right. So I think that's all that I wanted to say. The rest of the time is yours to get started.